Okay, which all shapes I can get from the section of a cone. So I may get, has anybody answered?
Circle, sir.
Circle. Of course, you may get a circle if I have a cutting plane which is parallel to the base. I may get a circle.
Ellipse.
So, okay, I may get an ellipse if I
Diagonally.
cut, okay, like this. And
Triangle.
yes, of course, I may get a triangle if I cut this like this. I may get a triangle. Then,
A parabolic shape.
yes, I may get a parabola. Say, let it be here. If I cut it like this, I may get a parabola. This could make a parabola. And even I can get a hyperbola. Okay, these will be the different shapes I may get. So I'll draw a reference diagram here. You may also draw down that. Is that okay? Okay.
Yes, sir.
Yes. So here I have. Okay, I'm just drawing the front view. You may also draw the same. And in order to show that it's a front view of a, okay, I'll draw that with a scale. Let it be. In order to show that it's a cone, you may draw this top view as a circle at the bottom also.
Sir, this is rough, right?
Yes, let it be rough. It's okay, but if you can draw a triangle without scale, it is okay. A perfect triangle. There is no dimension. Okay, Roshni. So this is the front view of a, say, front view of the cone. So section of cone. Okay. And if I cut this parallel to the base, if I cut this parallel to the base, say I'll draw a section line here. Okay. So this section I'll name as AA. A, A. I'm looking from the top. Okay. Then next one I'm going to draw another one which is inclined. Say let it be like this. If you have different color pen, you may also use that, not to avoid confusion. So this is my BB. BB. Now the CC. Okay, I'll draw CC. This is C. C. And if I draw a a cutting line which is perpendicular to the base. That be EE. And the next one, please be careful. Next one is important. Okay, this you can draw at any angle. But the next one I'm going to cut with the same angle as that of this generator. That is parallel to the generator. Do you get it? Parallel to the generator. So that I may name as D. So I have one parallel to the base, perpendicular to the base, inclined to the base but not cutting the base, inclined to the base and cutting the base, a general one, and another one with the cutting line parallel to the generator. And the last one, probably, and this I may name as F. So I hope you can see all the cutting lines. Yes, right, you can see. So I'll name which all shapes I'll get. AA, what will be the shape?
Circle.
Yes, circle. That will be circle. Then BB,
Ellipse.
yes, ellipse. Then CC is actually hyperbola. And DD, that is cutting parallel to the generator, that will be a parabola. And EE will be a rectangular hyperbola. And FF, can you say?
Triangle.
Yes, it will be an isosceles triangle. Is that clear?
Yes, sir.
Could you complete this?
Not yet, sir.
Okay, can you tell, is it visible? Should I keep the camera closer?
It's
Should I?
okay, sir.
That's okay. Okay. Keep a little bit closer. And so please tell me once you finish, we can try some problem with this cone. In the video, it is discussed like how the ellipse is getting from a cylinder, right? When the minor axis and major axis is given, you can draw the section in, right? I think it is discussed in the class, I mean in the video, right? ആണോ ആരും കണ്ടില്ലേ? Varun,
Yes, sir.
was it discussed like when major axis and minor axis is given, minor that diameter is given?
I don't think so. Only that True shape was there. I don't think that one is there.
I think there was a problem in which the cylinder is being cut.
Cylinder, no, there's no cylinder problem. Okay. But I'm not sure.
There is. There is.
Yes, sir.
Did you watch the video?
Sir, I only watched half.
Okay, Ruben.
Yes, sir. Somebody was asking a doubt about the cylinder. That's
Okay,
what we didn't do. They didn't do a problem.
problem. Okay, it's just discussion, right?
Yes, sir. A doubt somebody asked.
Okay, okay. Let me see whether that question is available so that you can also try that. Welcome back. Now let us see what is. Are you back?
Yes, sir.
Welcome. Yes. So we'll see what is regarding tetrahedron. So the tetrahedron was not introduced in, say, projection of solids. So we will see that here. So what's the difference between a cube as well as a square prism? Square prism ക്യൂബും തമ്മിലുള്ള വ്യത്യാസം എന്തായിരുന്നു? Can you say?
Height difference.
Yes, height difference. More precisely, if I can say, if actually the cube is a square prism, lateral edges having the same dimension as that of base edges, right?
Yes, sir.
Yes, sir.
Yes. So it's a special case. Similarly, a tetrahedron is actually a triangular pyramid. See, a triangular pyramid with its slant edge having the same length of the base edge. So it may look like something like so it may something like this. Although it's not perfect. You see? Can you get it? Are you getting it? A triangular pyramid. A triangular pyramid with the slant edge having the same length as that of base edge. That is called a tetrahedron. Do you get it?
Yes, sir.
Yes, sir.
So, what will be the shape of the faces? Or before that, how many faces will be there?
4.
4.
Yes, there will be 4 faces. And how many edges will be there? One, two, three, four,
7.
5, 6. 6 were.
Yes, sir. 6.
3 base edges, 3 slant edges, all of them having the same dimension. And what will be the shape of that face?
Triangle.
Yes, equilateral triangle. All the 4 triangular faces will be having equilateral triangle in shape. Like in cube, we have all 6 faces with a square shape. Here we have all 4 faces with a equilateral triangle. So this is the shape of a tetrahedron. Tetrahedron is nothing but a special case of a triangular pyramid whose base edge and lateral edges are having the same dimension. Okay, in most of the cases, especially in the case of section, we will draw the tetrahedron in this manner, usually in a corner position. Unless it is specified, we usually draw the tetrahedron like this. Say the top view is an equilateral triangle, and if I project it, I shall draw the top surface also. Say this will be the center, so the axis must be here. How can I complete this one? Any guess? So this is the top view, A, B, C, O. So this is actually B dash, C dash, this is A dash. And O is somewhere here. How can I complete this front view of the tetrahedron?
By taking 60 degree.
By taking 60 degree from here.
Yes, sir. To the axis.
Okay, so you are considering that the front view will be also an equilateral triangle. ആയിരിക്കോ?
No, sir.
No, sir.
No. കാരണം നമ്മളൊന്ന് ചിന്തിച്ചു നോക്കി, ക്യൂബ് വരയ്ക്കുന്ന കേസിൽ when cube was in corner position, you know that the front view was not at all a square, it was a rectangle, right? This was a rectangle, although all the surface of the cube has square shape. This was a rectangle, right?
Yes, sir.
Yes, similarly ഇവിടെയും അങ്ങനെ ചെറിയൊരു ട്വിസ്റ്റ് ഉണ്ട്. ഞാൻ പറയുന്നു AC, AB, BC, സേ അതിൻ്റെ ഒരു സൈസ് എന്ന് പറയുന്നത് 60 mm ആണെന്ന് വിചാരിക്കുക, ഫോർ എക്സാമ്പിൾ. സോ AC is 60, AB is 60, BC is 60. Of course, you can measure that because it is having true length here. And AO is also 60. But in top view, it may not be 60, but actually the edge capital A, capital O is also 60. Capital B, capital O is 60. Capital C, capital O is 60, right? That is how I defined the tetrahedron. All the edges are having same dimension, right?
Yes, sir.
Yes. And I have marked the center over here. And in front view, which all edges will have a true length?
AO.
Yes. Any other edges?
Rest are inclined.
Yes. All the top view lines are inclined, which is not parallel to XY line, except AO, right? ശരിയാണോ?
Yes, sir.
So in front view, only A dash O dash will have true length. ശരിയല്ലേ?
Yes, sir.
And what is that true length? In this case, it is given as 60. ശരിയല്ലേ?
Yes, sir.
So I'll mark A dash O dash with a length 60. I know that O and O dash will be in this line. So this point is O dash. So I got this edge with the same 60 mm. And the rest I will join. So this is how the front view is going to look like. Do you agree?
Yes, sir.
Okay. So this is basically how we keep the tetrahedron for section, unless otherwise it is specified. Okay. അപ്പോൾ നിങ്ങൾക്കൊരു ടെട്രാഹെഡ്രൺ വരയ്ക്കാൻ പറ്റുമോ പെട്ടെന്ന്? സെക്ഷൻ ഓഫ് ടെട്രാഹെഡ്രൺ. I'll name it here. Section of tetrahedron. So I told you how to draw the tetrahedron. So it's in the corner position. You got a triangle. Say you take 60 mm if it is possible, because we need to draw the section lines. So you can mark it 60 mm. And you draw an equilateral triangle, find the center, and draw this line for finding O dash. And from A dash, you can mark true length, which is 60 mm. You'll get O dash here. From there, you can join to B dash, C dash, and complete that triangle. Can you draw this?
Yes, sir.
Yes, please do draw. After that, I'll show which all shapes that we will get while section the tetrahedron. I shall draw one more triangle here. Exact dimensions. Could you complete that? Did you complete?
Yes, sir.
So which all shapes I may get? Okay, first one. First one I'll cut it here, parallel to the base. this is A and A. What will be the shape I'll get?
Triangle.
Triangle, bro.
Yes. What type of triangle?
Equilateral.
Yes, it should be an equilateral triangle. Okay. Then if I have a cutting line which is parallel to this true length slant edge. We have a cutting edge parallel to the true length slant edge. So if I cut a parallel to the true length slant edge, how many edges are being cut? See, while I cut this, okay, should I name it? If I name it P, Q, R, S. So this is P dash. Okay, I'll just name it caps to identify P. Or should I go for small letter? Yes, let it be Q. And this is R. Okay, so this is Q dash, R dash. This is S dash. So while I cut here parallel to base, actually this cutting plane is cutting S dash P dash, S dash R dash, S dash Q dash. So three edges are being cut. You are getting a surface with the three edges or three corners. That is a triangle. So since it is parallel to the base and base is having an equilateral triangle shape, you will get an equilateral triangle itself of a smaller size. While I have this BB, which is parallel to the true length edge, how many edges are being cut? Somebody said the answer. Who was that?
4.
Yes, it's 4. Actually, S R, S dash R dash, S dash Q dash, and here two edges are being cut, and here P dash R dash, P dash Q dash. These two edges are being cut. So what will be the shape you are expecting? And here this distance and this distance remain same. This distance and this distance remain same. Yes, it would be a rectangle. So AA, it's an equilateral triangle. BB will be a rectangle. So if I adjust this rectangle, I can make it a square. Okay. So how can I make it a square? I can take the midpoint of this line. Actually, midpoint of this line means actually I have two lines, S dash R dash, S dash Q dash. So I took the midpoint over here, and I took another midpoint, P dash R dash, P dash Q dash. I took the midpoint over here. So while I join, I'll get again a line which is parallel to this true length line. So this is a special case. So let me name it as C. So CC will be a square. CC will be a square. Do you get it? See, if you want to see how the rectangle is being obtained or how the square is obtained, I'll show that. This would be midpoint, right? So this is the midpoint. This is the midpoint. And here this will be the midpoint. And this will be the midpoint. So while I section that, I may get the top view like this.
So this parallel line drawn at the midpoints, it will have half the length of the base, right? That's
Pardon?
That's how we're getting square, right? Like between these 2 points when you're drawing the line, uh, like parallel to the base, is the what will be the length? Like half the length of the base, right?
No, half of the length of this line. Although it is not having true length, whatever length you have, take the midpoint.
Oh, okay, okay.
Here also, whatever length is there, take the midpoint. So midpoint will not change. You know that true length ആണെങ്കിലും apparent length ആണെങ്കിലും midpoint എന്ന് പറയുന്നത് midpoint തന്നെയായിരിക്കണം. ശരിയല്ലേ?
Yes, sir.
Midpoint means left and right will have the same dimension. So if I project these lines, say I have two cutting points here, here, and two cutting points on the base, I get here. So I'll get a shape like this. Of course, it doesn't look like a square, I do agree, but it is not a true shape. In order to get the true shape, you have to make it tilted parallel to xy line. You will get a square. Because this point is actually the midpoint of 60. This is actually midpoint of 60. This is midpoint of 60. This is midpoint of 60. So on joining that, you should get a square. Anyway, so these are the three shapes. And one more is there. If I have a cutting line which is inclined, ഈ പറഞ്ഞതൊക്കെ true length generator parallel ആയിരുന്നു. True length slant edge in parallel. But if I have a cutting edge which is not parallel, so let this, I name it as a D. So what will be the shape of this one? Okay, if you want, I will project that to here. So this will be the two edge points here, and on base I have these 2 points. So this is a newly formed surface, the top view. What would be the shape?
Trapezium.
Right, that would be a trapezium. So these are the different shapes that you may get from the tetrahedron. Can we go for a question? If you have completed this, do you need time to complete?
Yes, sir.
Yes. So please let me know once you finish. And please do remember something. While you draw the tetrahedron, most of the time while students are making the mistake is like they will draw the top view correctly. Okay, they'll draw the top view correctly with whatever dimension is given. And next, the mistake that you are going to make is like you will take the height as the same as the base set. It's wrong. It's not the height which is equal to the 60 or whatever dimension is given. It is the true length of the edge is 60. So here only true length is this one, whose top view is parallel to xy line. So you should draw that with the same dimension and then just join the triangle. So don't make that mistake. Please do remember, in tetrahedron, all the edges are having same, not the axis. Have you finished that? Hmm?
Yes, sir.
Yes. Okay. One more thing I would like to let you know. Okay. The problem that you have that we have seen, the cone. Can you take the question? Have you taken that?
Yes, sir.
Okay. Can you write? Okay. You have written it like the parabola of base 50 mm and altitude 60, right?
Yes, sir.
So in the base is 50. You write something in bracket as a double ordinate. It's the actual uh, technical term. Double ordinate is 50. And altitude is named as abscissa. ABSCISSA. Clear or no? Whatever we have written as base, it is a double ordinate actually, and altitude is abscissa. Clear?
Yes, sir.
Yes. So when question is asked like that, you don't get confused. It is like that. So shall we do a tetrahedron problem? Are you ready?
Yes, sir.
Okay, right. Please note down the question. A tetrahedron of 50 mm edge. A tetrahedron of 50 mm edge is resting on a face on HP. Is resting on a face on HP. It is cut by a plane. It is cut by a plane in such a way that in such a way that such a way that the true shape of the section is a trapezium. True shape of the section is a trapezium. With parallel sides 20 mm and 30 mm long. So trapezium will have two sides which are parallel, one of which is 20 mm and the other one is 30 mm. Draw the sectional views and the true shape of the section. Draw the sectional views and true shape of the section. Is that clear? Is the question clear?
So can you repeat the first line?
A tetrahedron of 50 mm edge resting on a face on HP.
Thank you, sir.
Okay. So how this could be? You can easily draw a tetrahedron. So I just draw this in a rough condition. So this is how we get it. And I need a trapezium. Trapezium കിട്ടണമെങ്കിൽ എന്ത് വേണം? ഇവിടെ നിന്ന് ഇവിടേക്ക് കട്ട് ചെയ്യണം, right? So here I'll get 2 points. Here also I'll get 2 points, right? Right?
Yes, sir.
And you can see that even if I cut and I'll get a trapezium, see this edge is parallel to the base, right? കാരണം ഇത് ഇങ്ങനെ നിൽക്കുന്നത്. It is perpendicular to the vertical plane. These 2 points I'll get, say 1, 2, and this is 3, 4. So 1, 2, the line is actually perpendicular to VP. ശരിയല്ലേ? That's why it looks like a point, right?
Yes, sir.
So that 1, 2 is perpendicular to VP means it is parallel to HP. So this is my 1 and 2, right?
Yes, sir.
Is it? So if it is parallel to HP, the top view will have true length, isn't it? Confusion.
Yes.
If it is parallel to HP, it should have true length in the top view. Similarly, 3, 4 is perpendicular to VP. That means parallel to HP. So the projection will have true length. Say this is 3 and 4. This will also have true length. But this will vary. ഇത് ട്രൂ ലെങ്ത് ആയിരിക്കണമെന്നില്ല. ട്രൂ ഷേപ്പ് വരച്ചാൽ മാത്രമാണ് ട്രൂ ലെങ്ത് വരുള്ളൂ. But this true length will remain as true length in the top view. And in this question, it is given that this is 20 and this is 30, right? തന്നിട്ടില്ലേ?
Yes, sir.
So all I have to do is I have to mark 20 here and 30 here. So this will be the section top view. So if I project this up, this and this will be my section line. ശരിയല്ലേ? ഇത് 20, ഇത് 30. So I'll get the corresponding points over here and over here. So this will be the section. You get it?
Yes, sir.
ഇതിൽ ശ്രദ്ധിക്കേണ്ട ഒരു കാര്യം, നമ്മളിവിടെ 20 മാർക്ക് ചെയ്യും 30 മാർക്ക് ചെയ്യും, ദാറ്റ്സ് നോട്ട് എ ബിഗ് ഡീൽ. ഇവിടെ നിന്ന് പ്രൊജക്ട് ചെയ്യുമ്പോൾ ചിലപ്പോൾ ഇതിങ്ങനെ പ്രൊജക്ട് ചെയ്ത് നമ്മളിവിടെ ബേസിലെത്തുമ്പോൾ നിൽക്കും. But it is not actually on base. This point is on BO and this point is on CO. So you should very vigilant in that case. It should be on B dash O dash and C dash O dash. So this will be 1 dash and 2 dash. This is 1 and 2. But here while I project, it should not go up. മുകളിൽ പോയി ടച്ച് ചെയ്ത് കഴിഞ്ഞാൽ അവിടെ ഒരു പോയിന്റേ ഉള്ളൂ. ബേസിൽ മാത്രമാണ് എനിക്ക് 2 ലൈൻ ഉള്ളത്. So it should be on A dash C dash A dash B dash because it is on AC and AB. So this is 3 dash and 4 dash. 3, 4. So I can join this. I'll get the sectioned top view. This will be the sectioned front view. And I may get the true shape on the right hand side if I draw this. It's clear? Is it clear?
Yes, sir.
Can you do that? I'll wait.
Sir.
Yes.
So in the top view, what is the fastest way to get the center of the triangle? O.
This one. This one.
Yeah.
If the dimension is given, like the base edge is 60 mm.
Yes, sir.
Yes. So you just take at 30 you mark a point. Here also mark a point 30. midpoint of this edges. See, നമുക്ക് ഇങ്ങനെ ഒരു ട്രയാങ്കിൾ ഉണ്ട്. ഇത് 60 ആണ്, ഇത് 60 ആണ്, ഇത് 60 ആണ്. ഓക്കെ.
Yes, sir.
സോ ഇതിന്റെ 60യുടെ പകുതി 30, ഇതിന്റെ 60യുടെ പകുതി 30. അതിന്റെ ഓപ്പോസിറ്റ് കോർണറിൽ നിന്ന് അവിടേക്ക് വരയ്ക്കുക. You will get the center.
Okay, sir. Got it, sir. Okay.
And also try to draw the true shape. Okay. Did you get it?
Still doing, sir.
Finished? കഴിഞ്ഞോ?
Yes, sir.
Yes. So I'll give two questions. I'll tell how to do that, but I may not be able to make you do in the class. So please note down the question. First question, a pentagonal pyramid of base 30 mm, a pentagonal pyramid of base 30 mm and height 60 mm, 60, is resting on its base. A pentagonal pyramid of base at 30 mm and height 60 mm is resting on its base. On HP, sorry, on its base on HP, with one base edge perpendicular to VP. With one base edge perpendicular to VP. It is cut by a cutting plane. It is cut by a cutting plane in such a way that, sorry, it is cut by a cutting plane, sorry, perpendicular to VP. It is cut by a cutting plane perpendicular to VP. It is cut by a cutting plane such perpendicular to VP such that the true shape of the section, the true shape of the section is an isosceles triangle, is an isosceles triangle of maximum possible base, of maximum possible base and maximum height. Draw the front view, top view, and okay, side view is not required. True shape. Should I repeat the question?
Yes, sir.
A pentagonal pyramid of base 30 mm and height 60 is resting on its base on HP with one base edge perpendicular to VP. It is cut by a cutting plane perpendicular to VP such that the true shape of the section is an isosceles triangle of maximum possible base and maximum height. Draw the front view, top view, and true shape. ഒരു പെന്റഗണൽ പിരമിഡ് ഉണ്ടെങ്കിൽ അതിൽ നിന്ന് കിട്ടാവുന്ന മാക്സിമം സൈസുള്ള മാക്സിമം സൈസുള്ള ഐസോസലസ് ട്രയാങ്കിൾ എങ്ങനെയായിരിക്കും?
Joining 2 points on the base.
ഈ രണ്ട് പോയിന്റ് ബേസിൽ ജോയിൻ ചെയ്താൽ മതിയോ?
No, you have to leave 1 point in the middle.
ഓക്കെ, ഐദർ ഈ രണ്ടെണ്ണം,
Yeah.
അല്ലെങ്കിൽ ഇത് രണ്ടെണ്ണം, അല്ലെങ്കിൽ ഇത് രണ്ടെണ്ണം, ശരിയല്ലേ? അതാണ് മാക്സിമം നമുക്ക് കിട്ടാവുന്നത്, ശരിയല്ലേ?
Yes, sir.
സോ ഐ മേ ഗെറ്റ് എ ട്രയാങ്കിൾ. ഓക്കെ, ഞാനിങ്ങനെ കട്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഐ മേ ഗെറ്റ് എ ട്രയാങ്കിൾ ഓഫ് മാക്സിമം സൈസ് എന്ന് പറയുന്നത് ഇതാണ്. This would be the maximum size I may get. Clear ആയോ? Clear ആണോ?
Yes, sir.
Yes. So the പെന്റഗൺ അങ്ങനെ വരച്ചു, നിങ്ങൾ സെൻറ്റർ കണ്ടുപിടിച്ചു. സേ ഇങ്ങനെ വരച്ചു. ഇനി ഇതിനകത്തൊരു കട്ടിങ് ലൈൻ വരയ്ക്കണം സച്ച് ദാറ്റ് മാക്സിമം കട്ട് ചെയ്ത് പോകുന്ന രീതിയിൽ. സോ ഇവിടെ നിന്ന് ഈ അപെക്സ് വരെയായിരിക്കും നിങ്ങൾ കട്ടിങ് ലൈൻ വരയ്ക്കാൻ പോകുന്നത്. അതായത് ഒരു കോർണറിനെയും അതിൻ്റെ സ്ലാൻഡ് എഡ്ജിനെയും നിങ്ങൾ ഒഴിവാക്കി. റൈറ്റ്, ഈ രണ്ട് പോയിന്റും അപെക്സും ജോയിൻ ചെയ്തിട്ടാണ് കട്ടിങ് ലൈൻ വരയ്ക്കുന്നത്. കൺസെപ്റ്റ് ക്ലിയർ ആണോ? ഇതാണ് ആക്ച്വൽ കേസ്. ഇത് അവിടെ വെച്ചിട്ടുള്ള പൊസിഷൻ, അതായത് വൺ ബേസ് എഡ്ജ് പെർപെൻഡിക്കുലർ ടു VP വെച്ചിട്ട് വരയ്ക്കുമ്പോൾ ഇങ്ങനെയാണ് കട്ടിങ് ലൈൻ വരാൻ പോകുന്നത്. ശരിയല്ലേ? ക്ലിയർ ആണോ?
Yes, sir.
Yes, sir.
Yes, sir.
റൈറ്റ്. ഇങ്ങനെയാണ് കട്ട് ചെയ്യേണ്ടത്. അതായത് ഓൾട്ടർനേറ്റ് രണ്ട് പോയിന്റിനെ വെച്ച് കട്ട് ചെയ്താലാണ് മാക്സിമം, അതാണ് നമുക്ക് മാക്സിമം വിഡ്ത്ത് കിട്ടാവുന്നത് ഒരു പെന്റഗണകത്ത്. മാക്സിമം വിഡ്ത്ത് കിട്ടാവുന്നത് കോർണർ ടു കോർണർ. ഒരു ഹെക്സഗൺ ആണെങ്കിൽ നമുക്ക് ഓപ്പോസിറ്റ് കോർണേഴ്സ് എന്ന് പറയായിരുന്നു. കാരണം പെന്റഗണകത്ത് അങ്ങനെ ഓപ്പോസിറ്റ് കോർണർ എന്ന് പറയാൻ പറ്റില്ല, ഓഡ് നമ്പർ ആയതുകൊണ്ട്. ഇതിനകത്ത് അപ്പോൾ ഓൾട്ടർനേറ്റ് ആയിട്ടുള്ള രണ്ട് പോയിന്റ് എടുത്തു. ദെൻ അപ്പെക്സ്, ഇതാണ് മാക്സിമം സൈസിൽ കിട്ടാവുന്ന ഇക്വലേറ്റർ ട്രയാങ്കിൾ. സോ അത് കട്ട് ചെയ്യുമ്പോൾ അതിനനുസരിച്ച് ഫ്രണ്ട് വ്യൂയും ടോപ്പ് വ്യൂ നോക്കി വരച്ച് കഴിഞ്ഞാൽ കിട്ടും. ഇനി ഒരു ക്വസ്റ്റ്യനും കൂടി എനിക്ക് പറയാൻ, ദാറ്റ് യു ക്യാൻ ട്രൈ യുവർ സെൽഫ്. ഐ വുഡ് ലൈക്ക് ടു ഷെയർ ദാറ്റ് ഓൺ. വൺ മോർ ക്വസ്റ്റ്യൻ യു മേ നോട്ട് ഡൗൺ. A cone of base is 60 mm. A cone of base 60 mm and height 70 mm. Is cut by a section plane such that the true shape is an ellipse. True shape is an ellipse of major axis 50 mm. Major axis 50 mm. Draw the projection of the sectioned cone and true shape of the section. Draw the projection of the sectioned cone and true shape of the section. True shape of the section. Find the inclination of the cone. Find the inclination of the cone inclination of the cone inclination of the cone if the inclination of the cone if the cutting plane passes through the extreme point of the base circle. If it passes through the extreme point on the base circle. Let me draw it first. Correction undo nokkate a second. Correct it. So this is 60. Axis having a height of 70. Okay, 70. Okay, this is the cone. It is cut by a cutting plane in such a way that true shape of the ellipse with the major axis 50. So major axis is 50. Okay, that's fine. That's not fine. Major axis, we shall say major axis is 70. Sorry about that. Can you correct the question? Can you correct the question, please?
Yes, sir.
Again, Vanda. Sorry, sir. A second. നല്ലൊരു ഡയമെൻഷൻ പറയാം, അല്ലെങ്കിൽ ഒരു കൺഫ്യൂഷൻ ആയി. ഓക്കെ, major axis is 60. You can take it 60. Sorry about that. Okay, a cone of base 60 mm, height 70 mm is cut by a section plane such that the true shape of the section is an ellipse of major axis 60 mm. Draw the projection of the sectioned cone and the true shape of the section. Find the inclination of the section plane with HP if the section plane passes through the extreme point on the base circle. Passes through an extreme. രണ്ട് extreme ഉണ്ട്, ലെഫ്റ്റ് ആവാം റൈറ്റ് ആവാം, or you can write extreme left point of the base circle. That's all. Extreme left point on the base circle. So it goes like this. I have drawn it here. This is 60 and height 70. So in order to get an ellipse, I should have a cutting line which is cutting the lateral surface, not the base. So in the question it says that it passes through a single point. So it is not actually cutting the base, right? Base ine cut cheyyunnilla, ശരിയല്ലേ?
Yes, sir.
Yes, ഒരു പോയിന്റിലൂടെ പാസ് ചെയ്യുന്നു. It's not at all cutting that base circle, just passing through a point. So it says that it has a base circle 60, height 70. I have drawn here, and it says that it makes a cone with the true shape is an ellipse. Ellipse കിട്ടണമെങ്കിൽ എന്ത് വേണം? Incline to base cut ചെയ്യണം, ശരിയല്ലേ?
Yes, sir.
And it should not cross the base. അതായത് ബേസിനെ കട്ട് ചെയ്യരുത്, ലാറ്ററൽ സർഫസിനെ മാത്രമേ കട്ട് ചെയ്യാൻ പാടുള്ളൂ. സോ ഇവിടെ നിന്നാണ് പോകുന്നത്. സോ I should get an ellipse here, and the major axis of the ellipse in there. So if you have the ellipse here, the major axis, this is having a dimension 60. ശരിയല്ലേ? അങ്ങനെയാണ് ക്വസ്റ്റ്യനിൽ പറഞ്ഞിരിക്കുന്നത്. Okay, so I should take 60 from here and I'll cross it here. So this is my cutting line. It's not cutting the base, only the lateral surface. It is passing through a point, that's right, but it is not cutting the base. So this will give an ellipse with major axis 60, isn't it? Right?
Yes, sir.
Yes,
And
sir.
if you measure the inclination, you will get the final answer, which is the inclination of the section plane. Correct?
Yes, sir.
Yes. So ഇതിനകത്ത് നിങ്ങൾക്ക് ഫേസ് ചെയ്യാവുന്ന ഒരു പ്രോബ്ലം എന്ന് പറയുന്നത്, ഓക്കെ, നിങ്ങൾ ഇതിന് കട്ടിംഗ് പോയിന്റ്സ് കിട്ടാൻ വേണ്ടിയിട്ട് മേ ബി യു വിൽ ഡ്രോ ദ ജനറേറ്റേഴ്സ് ആൻഡ് ഓൾ. ഓക്കെ, അപ്പൊ എലിപ്സ് വരുന്നത് മിക്കവാറും ഇങ്ങനെയായിരിക്കും. അതായത് what I infer is correct. ഇവിടെ നിന്ന് തുടങ്ങും, ഇവിടെ ഒരു പോയിന്റ് കിട്ടുമായിരിക്കും, ഇവിടെ ഒരു പോയിന്റ് കിട്ടും, ഇവിടെ ഒരു പോയിന്റ് കിട്ടും, ഇവിടെ ഒരു പോയിന്റ് കിട്ടും. ഇവിടുത്തെ പോയിന്റുകളൊക്കെ വളരെ അടുപ്പിച്ചായിരിക്കും. So here the points will, it is not uniformly uniformly distributed. അത് ഇവിടെ കുറെ പോയിന്റ്സ് ഇങ്ങനെ അടുത്തടുത്ത് വരും, ബട്ട് ഇവിടെ പോയിന്റ്സ് തമ്മിലുള്ള അകലം കൂടുതലായിരിക്കും. You will observe that while you draw. This is what you are going to feel like. So ഇതിലൂടെ വരയ്ക്കുമ്പോൾ ഒന്ന് ശ്രദ്ധിച്ച് വരയ്ക്കണം. Is that clear? Clear?
Yes, sir.
Yes. So you may try these two problems. I'm not giving it as an assignment, but you can try it yourself because I already mentioned how to do that. And I shall give two questions as assignments, which is not tough ones. I'll post it soon. You can submit in the next week. And again, a reminder, you should have that isograph printed, at least 10 to 15 pages, so that we can draw isometric projection and isometric view in that graph. ഇനിയിപ്പോൾ അതില്ലാതെ വരയ്ക്കാൻ പറ്റില്ലെന്ന് വെച്ചാൽ വരയ്ക്കാൻ പറ്റും, but it will take more time because you need 3 axes in order to draw isometric projection. So one will be perpendicular to the baseline and one will be at an inclination 30 degree and another one will be at a 30 degree. So for all the dimensions you have to draw this one. So in isograph means you have a number of vertical lines, a number of 30 lines, a number of 30 lines like this. So anywhere you can draw. Nevin എവിടെ പോയത് നെവിന്? So is that clear? Any doubts? നമ്മൾ സെക്ഷൻ ഇവിടെ കൊണ്ട് അവസാനിപ്പിക്കുകയാണ്. സെക്ഷനിൽ ഒരു ടെട്രാഹെഡ്രന്റെ ഒരു ചെറിയൊരു ട്രയാങ്കിളിന്റെ ഒരു പ്രോബ്ലം ഞാൻ തരുന്നുണ്ട്. ആൻഡ് ഇഫ് പോസിബിൾ ദാറ്റ് എലിപ്സ് ഫ്രം എ സിലിണ്ടർ which was discussed in the video lecture in the last class. In the video I shared, actually a question discuss ചെയ്യുന്നില്ല എന്നാ പറഞ്ഞത്. So let me try whether I'll get the question or I'll try to give you a similar question. Okay. Shall I wind up? If you have any queries, you may ask. Otherwise, you can leave. Thank you.
Thank you, sir.
Thank you, sir.